Okay, thanks very much. Just 2 minutes on what Wave Energy Scotland is, for those that don't know. Wave Energy Scotland is a public sector organisation funded by the Scottish Government, part of Highlands and Isles Enterprise. Our main objective given to us by the Scottish Government is to deliver cost-competitive wave energy for Scotland. That's our main objective. And we do that by running a technology programme. It's funded by the Scottish Government to the tune of about £10 million a year. And you can see there the sort of headline figures. We've had 177 organisations involved in the programme so far over the first 3 years. We've committed £28 million, 70 projects across 13 different countries. And we currently have 4 sort of themes within that programme. Wave devices, we've got 4 wave devices that we're developing. Power takeoff systems, 5 power takeoff systems we're developing. We also have a control systems theme and a structural materials and manufacturing processes call. So that's what we're doing. That's not what I'm here to talk about today. David asked me to talk about lessons learnt. I'm going to talk about lessons learnt within the WES programme, but also looking back at the previous programmes in Scotland, which go back another sort of 15 years before the beginning of WES, and look at what happened there and what can be taken in terms of lessons learnt. WES was formed in 2014 as a result of a sort of crisis in confidence of investment in wave energy within Scotland, a number of high sort of profile failures that we all know about, Aquamarine, Polamis and the likes. And when we started, we were very keen to try and capture the good parts of that because, you know, there were failures, but there was a lot of very good engineering that went on. And we captured some of that within the programme. 3 of our 4 developers came out of the previous wave programme. Richard's here from Polamis. PTO is now in our programme and is now being adapted for another wave device, so that technology has been taken forward. But there's also a lot of other things that, you know, the other lessons that were learned that we couldn't directly take forward. So what we decided to do was run what we called a knowledge capture program, where we gave contracts to a number of previous developers to look carefully at what they did and try and identify some key lessons that could be taken forward by new developers. So we ran 5 projects, one with the Orkney supply chain and EMEC, and some of those that were involved in that are here today. Polamis and Quotient, AWS, Aquamarine Power, and Alberton. The only one we didn't get anything from was WaveGen, which had been taken over by Voith, and they were not really very interested. So we ran this program. We've collated all the information from those projects, and we've got it on a sort of document repository, an online repository, which is the WES Knowledge Library, which you can get to from the WES website. And all the projects are detailed in there. You can download the documents, and there is a wealth of information about all aspects of designing, developing, testing, and deploying wave energy devices. And there is some great stuff in there. And I honestly thought when we started this that no one would really tell us the important details. They wouldn't want to tell us what went wrong. But that's far from the truth. I mean, obviously, a lot of information does get lost when a company goes into administration, but a lot of the good stuff was captured there as well. So that's, I'm not sure you can actually see it with the screen that size. That's a screenshot of the knowledge capture page. And I'll just quickly go through them. The first one is about real sea deployments. That's the Orkney supply chain, a whole host of marine operators involved in that, and environmental consultants and EMEC. There are reports about compliance, handling, installation, O&M, all very useful things. And there's quite a lot of stuff in there that the stuff that the developers wouldn't tell you, that the supply chain perhaps will. So some valuable reading there. Aquamarine Power covered a number of subjects: offshore operations, corrosion and protection, supply chain, tank testing and maintainability. And there's some very good stuff on corrosion and protection there, because they had a number of issues with taking components from the oil and gas industry and from other sectors and fitting them directly into their device, and then finding that highly oxygenated water treated them completely differently than if they were 1,000 metres down in the North Sea. So there's quite a lot of good information about corrosion and protection. We did some work with AWS. They looked at development experience, the design process, and how you take forward the development of a wave device and the critical elements. Quite a lot on cost modelling as well within that package, which is quite useful. And then the Polaris work carried out by Quotient, which is much more comprehensive than any of the others. It talks about lessons learned, but it all talks about the technology that they developed as well, and some details about how that actually works. So there's projects on tank testing, PTO, moorings, connections, simulation and modelling, and economics that are all quite comprehensive. We also did some work with Albertern. Their particular interest was aquaculture, and there's some quite good projects on aquaculture and the application of wave energy to it, and the international markets for aquaculture as well. There are a couple of other things on the knowledge library as well. We have an O&M simulation tool that actually started life at Polaris. It then was modified for Albertern, and then we took it on and made it more generic. So it's a complete O&M simulation package. You can download it, you can use it. It's got a user guide, it's got default data in there. It's got a whole host of stuff to just give you a head start in understanding how your O&M sort of maintenance policy strategy can be structured. There's also some stuff on metrics, some metrics work that we're doing with the Automobile Commission and the IEA about how you actually assess performance and what is a good performance for a wave energy device. So there's some useful information about that as well. So that's pretty much everything. I'm not going to go into the details of all the lessons learned. I think we've done a reasonably good job of characterizing it and putting it in an easily user-friendly format that you can have a look at and you can browse through. So please make use of it. It's there for the benefit of everyone. And really, just overall, all I would say is the one theme that runs through all of these lessons learned is generally that those that took on too much technical risk, and Sam's talked about how he's approaching trying to avoid doing that. Those that took on too much technical risk in their programs, and many of the Scottish developers did, found that those risks were always realized, and they had a huge impact on their programs. Some of them were put out of business by it, some of them their whole program halted, but generally that was the process, too much technical risk, and it comes back to bite you. And I would agree with what Sam was saying about adding systems and keeping adding systems. Engineers are wonderful at solving problems, and if you've got a problem, they'll give you a system, they'll give you a mechanism to solve it, and add another one, and then add another one, and often the answer is to just go back a bit and say, well, can I change the design so I don't need that, and design out the problem. Okay, that's it from me. Thanks very much.